Okay, cool. Let's quickly start this session. And yeah, just give me a second. Any idea how we can share multiple windows? And let me just share this entire screen. Okay, so hopefully you guys can see my screen, right? Cool. Hello, everyone. This is Amit, and we will be discussing about AWS basic networking. Okay, so I assume that you guys already know what is AWS, right? So AWS is nothing but a public cloud offering, which is by Amazon, right? And it is, I think, the most popular public cloud that we have on the planet right now. Okay. And they offer a lot of services, right? They offer infrastructure as a service like EC2, which is virtual machines, right? They offer storage, right? So storage like EBS, NFS, etc. And then they offer platform as a service, which is, for example, EKS, which is Kubernetes, right? Or Elastic Beanstalk, which is nothing but a web application deployment platform, and then software as a service as well, right? Many software services like S3. So now question is, what are we talking about here in AWS basic networking? So here we are going to talk about how your resources on AWS are kept private to you, away from all other people and organizations who are setting up their own resources on AWS, right? So to maybe visualize this better, so let's say this is whole AWS, right? This is whole AWS. And on AWS, there are people like me or like you who must have created their personal accounts, right? So account one, and then some more accounts like account two. And then there would be other companies who would have created their account. Maybe HSBC Bank has their resources on AWS. So we have HSBC, right? Or maybe Citibank has their account here. And they create their own virtual machines and security solutions, whatever solutions they have. Now I can create a VM here, right? Citi can create a VM here, but it's all in the same AWS infrastructure. So then, can I access their VM? Or can this account access this VM or the VM here? Or maybe a storage or a database here? Can they be accessed? Right? So I'm going to talk about that. How you keep things private within a bigger AWS infrastructure, right? So let's say this is AWS, right? In AWS, things are kept private using a concept called as a VPC. Okay. Things are kept private using a concept as VPC. So for example, Citibank would have something called as a, let's assume they have something called a City VPC. And HSBC may have their own VPC, right? And VPC stands for Virtual Private Cloud. So within the public cloud, you have a virtual private cloud. Okay, so Citibank has a virtual private cloud, HSBC has one, I may create one. Somebody can create 10 different clouds. So maybe Citibank can create 10 different clouds also, right? And they can create all resources here. They can create EC2 instances. They can create Kubernetes cluster, right? They can create a lot of resources here, which are private to this cloud, which are only visible within this cloud. So a VPC is like a private section in this entire AWS infrastructure. Okay. And private means nobody can get in, nobody can get out. Okay. This is restricted. You can enable these like getting in, getting out, but by default, it is disabled. Okay. So that's VPC. So let's get into a bit more detail on what goes inside a VPC. So let's say this is my VPC. Now this is City VPC. Now a VPC can spread across multiple data centers. Okay. And a VPC can have a large number of IP addresses. For example, it can have 10.0.0.0 slash 16, right? So this could be the CIDR for this VPC. That means it can have IP addresses from 10.0.0.0 to 10.0.255.255. So imagine how many um, IP addresses would be there, right? So many IP addresses within this VPC. So it's very difficult to manage resources in a very big network. So generally in the network, there is a concept of subnets, right? So you create smaller networks within a bigger network. Same goes here as well in a VPC. So you create smaller pieces of network. These are called subnets. So I can say this is subnet 1, this is subnet 2, right? And this is subnet 3. And these can have their own CIDR. This can have a subset of whatever is the global CIDR. So 10.0.25.0 slash maybe 22, right? This can have 10.0.21.0 slash 22. So this is now a subnet of this IP address set. Okay. Similarly, subnet 3 can also have. So the advantage is now any resources that you will create here, any EC2 instances, any databases, any Kubernetes clusters, they have IP addresses from within this range. Okay, so they will have IP addresses from within this range. These will have IP addresses from within this range, right? And by doing this, you can manage the resources easily. You can also, you know, provide or enforce some network policies on these subnets. For example, this could be your prod subnet. This could be your dev subnet. This could be your public subnet. That means in this prod subnet, all the resources are only reachable within the subnet. Nobody can access them from outside. In this dev, maybe other resources can access, but nobody can access from outside. Okay? But maybe a public subnet, you can create resources which is accessible from internet. Right? So it can be accessible from internet. You create public resources here. Okay, so you can govern the ingress and egress of resources of communication on each subnet, right? So now let's talk a little bit about how you can implement those resources, right? How do you implement who can get in, who can get out? Okay, so just give me a second. Right, so let's take an example of an EC2 instance, a virtual machine, which is created in a subnet, right? So let's say that this is my VPC, right? This is my city VPC. And in this VPC, there are multiple subnets. So let's say this is subnet 1 and this is subnet 2, right? Subnet 1, subnet 2. Now in this subnet 1, at a subnet level, I can enforce some policies or some roles, right? So that is called network ACL, network access control list. In here, I can specify what kind of communication can come into this subnet and what kind of communication can go outside of this subnet. So what is the allowed communication into the subnet? What is the exiting communication outside this subnet? So what is allowed? What is not allowed? Okay. And that is defined using rules. So I can say some communication on some port where the source IP address is something. Do you want to allow it or do you want to reject it? So any communication from any IP address on port 20, on port 8080 or on port 443, maybe let's allow it, right? So on port 80 for any of the resources, if a communication coming on port 80 and coming from 0.0.0.0/0, that means any IP address, then allow it because it's a web port, right? Port 80 is HTTP port. So maybe allow it. But then we can say any communication coming on port 22 from 0.0.0.0, do not allow it. Right? So we can make rules like this, which define what is allowed to come inside this subnet and what is allowed to go outside of this subnet. And when you make a rule at a subnet level, it is applied to all the resources within the subnet. So if there are 100 virtual machines within S1, then all of them will have to follow this rule because it is at the network level. It is not at the instance level. Okay. Right. Now, let's say I create a virtual machine, or let's say there are two virtual machines in an subnet called S2. So this is VM2, this is VM1. And VM2, let's say it has a database running. And VM1 has a web application running. Okay. It is running web application on port 80 and database is running on, let's say, port 3306. Now this web application, well, when anybody accesses this web application, the front end talks to the database on port 3306 and gets a response and then delivers it to the front end, to the customer, right? Let's say we have these two VMs and this is an application stack. And our users are sitting over the internet, right? Let's say it is my e-commerce website and there are users over the internet. So users are going to connect via the internet to my VM on port 80. So they will say HTTP VM1 port 80, connect to it. Now, first thing is, if we want this communication to get in, we should allow at the subnet level. So in the subnet, I can say allow access to any port, right, from any source IP. That means this subnet is freely accessible. But if that is the case, I can access this VM1 port on port 80. I can also will be able to access VM2 on port 3306. Now we don't want to do that. We never want to do that. Never expose your database to the external internet. So now how do we prevent this? Because anybody can access this subnet and all the resources because we have the NACL, which allows all this communication, right? So one way to prevent this is have a EC2 level or VM level firewall. Firewall at the virtual machine level. So what does that mean? That means regardless of what is the rule at S2, you can have some rules at the virtual machine as well. So you can say for this database, deny any request coming on any port from any IP address, but allow permission on port 3306 for VM1. Okay, this is allow, this is deny. So you can have such sort of rule associated with the EC2 instance, right? And this set of rule, which you can associate with an EC2 instance, are known as security group. It's called a security group. So you can create a security group. A security group is nothing but set of rules allowing and denying, which you can attach to a EC2 instance. Am I making sense till now? Or is it too much? If you're not coming from a cloud background, it might be too much for you. Right? Okay. GCP, I'll see if we get time. I'm not very well versed with GCP, but I can figure it out. All right. So you can associate this security group here with this VM. So then no communication will be allowed on this EC2 instance. Right? So this is how basic security is set up. There are other ways you can have more security. You can have VPC peering. You can have VPC gateway. You can have private links. But this is the basic of it. So as I said, we are going to cover the basic AWS networking. So let me show you how it can be done. So I already have a AWS lab. Okay. And let's go to VPC. Right? If I go to VPC, you can see here that there is one VPC that is already created for me. When you create an account in AWS, in each region, in each region of AWS, you will be getting one VPC. Okay. And if I select this VPC and click on resource map, you can see more details about this VPC. So this is the VPC. It is this ID of the VPC, and it has 6 subnets. You see, it has 6 subnets. Now, this VPC has IP address CIDR of 172.31.00/16. That means it can have IP address from 172.31.0.0 to 172.31.255.255, which is quite many IP addresses. Okay. So now you will have, now they have given me 6 subnets here, the default subnets. If I click on this, it says this is the CIDR 172.31.16.0.20. This one is 172.31.00.20. This one is 172.31.48.0.20. So you can see that the network is divided into smaller chunks here. And there are route tables for routing the communication and then internet connection with the internet gateway. But that's okay. We will ignore that. So there is a VPC, default VPC, which has subnets. Okay. Now let's quickly open EC2. And let's create an EC2 instance. So I will click on launch instance. And I can give it some name. And I can choose whatever here, instance type. The main important thing is the network settings. Now here you can see it has picked up the VPC. So this EC2 instance will be created in this VPC. Why did it pick up this VPC? Because this VPC is the default VPC. If I go here, you see here on the VPC information, this is the default VPC. So whenever I create any resource, if I don't explicitly provide any VPC name, it's going to pick up this default VPC, which is here. But I can change it. If I click on this edit, I can specify some other VPC, and then I can specify in which subnet the resource should be created and many other configurations. Okay, right. So that's how it is done. So what I'm going to do is we are going to create a new VPC. So you can create as many VPCs as you want in your account. Right? So I'm going to create a new VPC. Let's click on create VPC. And there are 2 ways you can create VPC in AWS. One is if you just want to create VPC and later you will create, internet gateway, routing tables, subnets. You can create all of them later, right? Or you can say, I want to create VPC and more. In that way, everything will be created for you. Right? So let's go this way, VPC and more. Name tag auto generation. So we don't want auto generation of VPC. I'll say SUR demo lab. This should be the prefix for our VPC. Now, what should be the IP address range? I can choose here. I can define whatever, and then choose the IP address range. It's up to me. I can make it maybe 8. Right? So it's up to me what I want. I choose this. IP6, we don't want IP6. Then how many availability zones we want? So I did not talk about availability zones, but you know that in a region there could be multiple data centers. Each data center is called as an availability zone. And the subnets have a very direct relationship between availability zone. Each subnet exists in one availability zone. Okay. All right. So here, how many public subnets I want and how many private subnets I want. So there is option of either zero public subnets or two public subnets or zero private subnets, two private subnets, four private subnets. Now, what is a public subnet and a private subnet? A public subnet has a internet router connected to it, which is called as internet gateway. Like if you have a laptop at your home or if you have a TV at your home or phone, it cannot connect to the internet if you don't have an internet connectivity, right? An internet router. So if you connect an internet router to your local Wi-Fi, then you get internet connectivity. Otherwise, all the devices can talk to each other, but none of them can talk to internet. So similarly, if you have public subnets, sorry, if you have private subnets, so these are four private subnets, they do not have any internet gateway connectivity. You see, network connection is just a local network connection. But if you have a public subnet, let's say this one, right? So you have these green ones are public, this A green and B green, and they are all connected to one router. And this router is connected to the internet gateway. This is an internet gateway, which allows you to have connectivity to internet. So you can create public subnets or you can choose not to create. I will just create them for fun. And that is all. Click on create VPC. It will take a little bit of time. So it's going to create all these things. And done. I'll click on view VPC now. And you see a new VPC is created for me. Let's go to your VPCs. Now there are two VPCs. This one is the default one, which pre-existed. This one is the new one that we have created. Okay, cool. So that's there. Now you can see at the VPC level, you have an ACL. You see main network ACL. This ACL, let's go to this ACL here. And this ACL has rule about what traffic can come into the subnet and then outbound rules, which says what traffic can go out of the subnet. Right? So that means here it's pretty liberal in this VPC. You see rule number 100, all traffic is allowed. Okay, similarly, all traffic is allowed to come in, all traffic is allowed to go out. There is no restriction. Right? And if you see in this, the other ACL, this one, this ACL, this also has a ACL created, right? And it is associated with all our subnets here for the new VPC. Okay. And this also has all incoming allowed for inbound and all allowed for outbound as well. All right. So let's create an EC2 instance now in the new subnet. So let's refresh this. And now there are two subnets you see here. Let me create EC2 instance here. And I can choose a subnet. Let's refresh this. Right. So now there are so many subnets you see here. And you can see in the naming itself that this is a private subnet. This is a public subnet. So if I create an EC2 instance in private subnet, I can never reach it from my laptop because there is no connectivity, internet connectivity. Right. if I can deploy on a public subnet, then I can reach it. So let's create it in a public subnet. And let's say it needs to get a public IP. So I assign that. Now security group. So we chose in which VPC and in which subnet we want to create this instance, right? But if I go back, that's this one. So the reachability of the EC2 instance will be defined by this one. But we can also have VM specific security group, right? So here we have to choose that. Now, security group, which security group do we want to associate with this? Now, there is one default security group that is created whenever you create a VPC. So there is a default security group. Let's explore that first. What does the default security group say? So in the EC2 networking, if I go to security groups, you can see here, there are default security groups, right? Which one is being picked here? It is the 1B, right? This one. So whenever you create a VPC, a default security group for that VPC is also created. Now this is a VPC, this is a default security group. And it says, if any EC2 instance has this security group associated with it, then for incoming communication, the only traffic that is allowed is all the traffic type on all the protocols, all the range, but all the other instances connected with this security group. No other instance or no other IP address can reach to it. But for outbound, everything is allowed. Okay, so there are no deny rules in security group. There is always allow. By default, it is default deny. So if you don't specify any rules, that means nothing will be allowed. So you only allow specific communication. Right. So let's click with this. Let's say I'm going to use the select existing security group. I'll use this one, which will not allow any communication into this EC2 instance. We will try to verify later, right? Okay, this is done. This is done. And as a launch instance. Key pair name. Okay, so I'll say proceed without key pair because I'm not going to log in. So this is the instance that is created. It is running, it has got its own public IP address, right? It has its own private address and public DNS and all. Let's take the public IP address. And I'm going to open my terminal. And let's say ping. I want to ping this IP address. Let me zoom this here. The instance is up, but I'm not able to reach it. Right? Why am I not able to reach it? So first, let's say this is me. This is my laptop. I'm trying to reach to this instance. First roadblock will be NACL. Is the network ACL stopping me from going in? So let's check that. This is the EC2 instance, and this is the VPC ID. This is the subnet, right? Let's go to security. This is the security group, and let's go to networking. This is the subnet, right? Let's go to this subnet. So it's connected to this subnet. Let's go to this subnet. And this is the subnet. Let's open this one. And it has a ACL, right? So let's look at the ACL. And it allows all the traffic. So I don't see that should be a problem, right? So this is allowed. Let's look at the security group. So now coming back to the instance now, there is security. And this is the security group here. It also shows the inbound and outbound rules here. So it says outbound is fine. It allows to this communication to exit from this EC2 to all these destinations, but incoming is restricted to this particular source. So now let's modify this security group. I'm going to say inbound rules. I click on edit inbound rules and I say allow all traffic from anywhere. You may not for an existing reference group. Okay, so let's add a rule, all traffic, anywhere, and this one I will delete. So now all the traffic is allowed from anywhere, and I save the rules now. Okay. So now what I did, I enable traffic from all the IP addresses. Now if I pick, now I'm getting a response, right? So security group is like a local firewall to my EC2 instance. Let's go back to the VPC here and let's go back to this ACL. And now let's add one rule in ACL to deny this. So I'll go to inbound rules. I click on edit inbound rules and I'll add a new rule. Now, each rule has a rule number, which is similar to priority. The higher the number, the higher priority it is. So the 100 rule number by default is which allows all the traffic. So let me create a higher priority rule than this. So I'll say 101. Okay. And I say allow all the ICMP traffic. ICMP is nothing but the ping traffic. Okay. So I say all ICMP traffic denied from anywhere. I'm adding this rule. So if I save changes now, now you see here there is a 101 rule, which denies all the ICMP traffic. ICMP is nothing but ping traffic. So now what's going to happen? As soon as I will send a ping command, it's going to reach to this NACL. NACL is going to evaluate all the rules, starting with the highest priority. As soon as any rule matches, it will take the decision based on that rule, but it will not go to the further rules, further down priority list. As soon as one rule is matched, it will just stop processing the rules and it will take the decision based on what the rule says. So now the first priority is 101. It's going to find out that it's a deny rule. So it's going to deny it. Let's see. Ping. For okay, hold on a sec. Let's change this a bit. That was a bad demo. Let's first try to make it as all traffic. Okay, I think it goes other way around, smaller to larger. All right, let's try that. Okay, this allows ping yet. All right, let me edit this. Maybe I'm mistaken. Let's make it as 99. And I say deny all ICMP. Yes, so now it is sorted, right? The smaller one. I think smaller one takes precedence. Right. So let me change what I said. The smaller one is higher priority. The smaller the number, the higher the priority. So now you see it is not allowing the ICMP traffic into the complete subnet itself. But if I say SSH, Now it goes till the system, and then it is asking if you want to connect or not. Why? Because the first rule did not match. It's not an ICAP communication, it's an TCP communication. So it goes to the next rule. Next rule says allow everything. So now it allows, and then it is serving the SSH1. If I create one more rule and I say rule number 91, and I say SSH should also be denied. So now if it finds that it's an SSH communication, deny it. So now that also will be denied. I'll not hear anything back. Okay. So you can restrict the communication for the entire subnet at the NACL level, or you can restrict it at a EC2 instance level using security groups. Okay. But doesn't matter how liberal your security group is. If there is something denied at NACL level, then it will be definitely denied for everything. So security group wouldn't even reach. Did I make sense? So this is what I wanted to talk about, like the basic networking in AWS. What is VPC? What is subnet? What is NACL? What is security group? And how these enable you to secure your infrastructure. Now I can take some questions and try to see if I can answer any of these questions. So open for questions now. Can we set firewall for entire VPC? No. So you can set up restrictions at subnet level itself. Can we add more than one protocols? No. So when you create inbound or outbound rules, you have to choose one protocol, have to choose one port, or if you choose type, then all these will be filled. Or you have to choose one protocol and one port and source as well. Okay, so you will have to create multiple rules. It's always good idea to create multiple rules so that you can manage them easily. Subsequent sessions, I will have to see if we can plan something. I can definitely plan. Please explain the 172.13.0.0. Okay, so right, let me explain CIDR. So whenever you have a network, you represent its IP addresses, possible IP addresses within a particular network using a CIDR, right? So that's called classless inter-domain routing. Okay. If I'm wrong, please correct me. So this defines how many IP addresses are possible in a particular network. It has this notation. So there is um, an octet, which is the IP address octet. So 02255, right? Dot 02255, which is like an IP address, right? 02255 dot 02255 slash 02255. Okay. So this can be, for example, 10.25.81.110 slash 21, something like this. So what does that mean? So this is the IP address range, and this is the subnet mask. So what does that mean? Now let's break this down into bits. So this octet, right? 1, 2, 3, 4. It contains of 8 bits. That's why it is 02255. So 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Right? So depending on this value, for 10, it would be, what is 10? 110 is 10. Right? So it will be like the 0, 0, 0, 0, 0, 110 dot, what is 25 in binary? I think this is 25. I've never, I've not done binary for a long time. So this is 1 and this is 8 and then this is 16. Right? So similarly, some bits here, some bits here. That will be set if it has to become like this. Now this 21 means first 21 bits are unchangeable. Okay. So that means this is 8 bits. This is 8 bits. And 16, 17, 18, 19, 20, 21. This much. So total 21 bits. These 21 bits are fixed. So in this particular network, which has this particular CIDR, this particular CIDR, so these many bits are fixed. They cannot change. Rest of them can be assigned as IP addresses. Okay, so that means whatever here that remains constant, and here you can say 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0. And this will become the full IP address for any system which is inside this. So yeah, CIDR.xyz is a excellent idea. Let me do that. Right? So let's say, what did I talk about? I said 10, 25, 81, 110, right? So 10, 25, 81, 110, 21. Okay. So this is the binary representation. So 10100001010. Yeah, I messed up here in the naming number. And 000110001. Yeah, so whatever, I mean, yeah. So this is there and this is there, right? So this represents the first 4 things like this. Okay. Now, if I give one network this particular CIDR range, that means that, and this is the subnet mask 51, that 21. So that means these many bits, the colored bits are fixed and rest of the bits are eligible for an IP address. Okay, so this becomes the first three bits will become 10.25.80. Yeah, it will be 0 to 32 after the slash. You are right, not 255. It can only be till 32. Okay, right. So these bits are fixed and these are available for assignment. So you can assign anything here. So that's why the total IP address will be 2048. So all the free bits that together become 2048 IP addresses. Okay. And if I say 10.0.0.0/16, that means first 16 bits are fixed, the rest are available. Make sense? So it means that I hope I was able to throw some light. Great. Any more questions? I think we are almost at the end of the time. So let's wrap it up today. Maybe in the next session, we will meet again. Okay, NACL and security group, which one is priority? Always NACL will be hit first. Once communication is allowed from NACL, then security group will come into picture. All right. Thank you guys for your time. Thank you for your patience. And I'm going to maybe see you around in some other discussion. Thank you. Take care. Enjoy the day. Bye bye.